Welcome to all in the next lecture that is on matrices introduction. So first we talk about the introduction about the matrices. So first starting about the matrices, what is the matrices? First we told about the what is the advantages of the matrix. So matrix algebra has at least two advantages. That first one is reduces complicated systems of equations to simple expressions. And second one, it is adaptable to systematic method of mathematical treatment and well suited for computers, right? So now what is the definition of the matrix? A matrix is a set of group of numbers arranged in a square or rectangular array enclosed by two brackets, like as here we use here the two brackets in the set of numbers, right? So if we enclose set of numbers by two braces, so that is called the matrix. Now the properties of the matrix is that a specified numbers are of rows and a specified number of columns. In matrix we have the rows and the columns, and two numbers describe the dimension or size of the matrix. What two numbers? Rows, total rows in that braces, and total columns in that braces. So that is rows cross columns that describe the size of the matrix. Like here, if we have this matrix, right? Here we have this matrix. So this is our the rows, and here these are our the columns. So always in the matrix these are the rows and these we count the columns. So how many rows are here? 1 2 3. So three rows are here. And how many columns? 1 2 3. Three columns are here. So what is the size of this matrix? The size of this matrix is 3 cross 3 matrix, because here we have the three rows and three columns. Similarly, if we have this type of matrix, so how many rows are here? 1 and 2. Two rows are here. And how many columns? 1, 2, 3, 4. Four columns are there. So what is the dimension of this matrix? That is 2 cross 4. First element represent the rows and second element represents the column. So this is the order of the matrix 2 cross 4. Similarly, if we have this type of matrix, how many rows are here? Here we have only one row. And how many columns? Columns are two, because in horizontal we have the rows and in vertically we have the columns. So here we have one row and two column. So what is the size of this matrix? That is 1 cross 2 matrix. Clear? Next, how to represent the matrices. A matrix is denoted by a bold capital letter and the elements within the matrix are denoted by lowercase letters, like that. This represent our the matrix. Here we represent our matrix A in the square brackets. So this is the representation of any matrix, and the elements of this matrix is type of A, I, J, where I is stands for the rows and J stands for the columns, right? So here, like that, we have the matrices, we have the elements are Aij types elements, A11, A12, Aij, Ain, and columns are A11, A21, Am1, like that. So these are the rows and these are the columns. So this is the representation of the matrix A, where the order is m cross n, because here we have the m rows and n columns. So we have the order is m cross n. We also represent our matrices is like that, m a n. So this is also the representation of the matrices. And here I goes from 1 to m and j goes from 1 to n. Now types of matrices, we have the many types of matrices. So in which first is the column matrix, or we say that the vector. So what is the column matrix? The number of rows may be an integer, but the number of columns is always 1. So which matrix? The matrix which has the any number of rows but column should be 1. So that type of matrix is called the column matrix. Like that, here if we have suppose this one, right? So here how many rows are here? Here you should check that here we have the 3 rows, this one, this one, and this one. So here we have the 3 rows, but how many columns? We have here only one column. So this is called the column matrix. Similarly, we have here how many rows are there? One and two. 2 rows are here, and how many columns? Columns are one. So this is the column matrix. Clear? If we like suppose we have here how many rows are there? Here we have the 1 2 up to m rows. So here we have the m rows, and column is only one. So this is called the column matrix. Clear? Next one is the row matrix. So what is the row matrix? Similarly, in the column matrix, if we have the number of columns but only one row is there, so that is called the row matrix. Like that, how many rows here? Here we have only one row, but how many columns? Columns are three. One, two, and three. Columns are three, but rows only one. So this is called the row matrix. Similarly, if we have this, how many columns are here? Here we have the 1, 2, 3, and 4. 4 columns are there. But how many rows? Rows is only one. Row is only one. So this is called the row matrix. Clear? Similarly, if we have the n number of columns, 1, 2, 3, n number of columns are there, but row is only one. So this type of matrix is called the row matrix. Clear? Next is the rectangular matrix. So what is the rectangular matrix? In which the matrix in which we have the one element and number of rows is not equal to the number of columns, means different number of rows and different number of columns, not the same rows and same columns. Like that, if we check this, how many rows are here? Here we have the rows 1 2 3 4. So how many rows are here? Here we have the 4 rows, and how many columns? Columns are here 1 and 2. So 4 rows are here and 2 columns are here. So this type of matrix is called the rectangular matrix, in which we have the rows and columns counting are different. Suppose it's like that. How many rows are here? 1 and 2. 2 rows are here, and columns 1, 2, 3, 4, 5 columns are there. So 2 rows are and 5 columns are there. So this type of matrix is called the rectangular matrix. Clear? M not equal to n. M represents are the rows and n represents the column. So M and n are different. So this is called the rectangular matrix. Next one is the square matrix. So what is the square matrix? Where we have the number of rows is equal to the number of columns. So that is matrix is called the square matrix. Means suppose, so here what will be the order of the matrix? Because here m and n both are same, equal. So order of this matrix is m cross m, right? So we can say that the order is m. Like that, how many rows are here? 1, 2. And how many columns are here? 1, 2. So both rows and columns are equal, same. Number of rows and number of columns are equal. So that is the square matrix. Like that, how many rows are here? 1, 2, 3. And how many columns? 1, 2, 3. So 3 columns are there, 3 rows are there. So this type of matrix is called the square matrix. Clear? And the main diagonal of a square matrix is all the elements a, I, j, for which I equal to j. Means here we have any element may be there in our diagonal elements 0, 1, 2, 3, anyone. Next type of matrix is diagonal matrix. So what is the diagonal matrix? A square matrix where all the elements are 0 except those on the main diagonal. So what is the main diagonal? If we have suppose this type of matrix, so what is the diagonal, main diagonal in the matrix? Actually this is are the main diagonal of the matrix. Any matrix we have, this is the main diagonal of the matrix. Not this one. This is not the main diagonal of the matrix, right? We have this is the main diagonal of the matrix. So for to become a diagonal of a diagonal matrix, it should be the square matrix, because if it is not the square matrix, then we can't say about the diagonal. So what is the diagonal matrix? In which we have the elements in only the main diagonal and non-diagonal elements are 0. So this type of matrix is called the diagonal matrix. Like here our diagonals are only 3, 3, 5, 9. So these are the diagonal elements. Only our diagonal elements are have the non-zero elements, other elements are 0. So this type of matrix is called the diagonal matrix. So we can say that our these all are the aij type elements, right? So aij equal to 0 for all I not equal to j, right? And the main diagonal elements are if I equal to j, because this is a11, a22, a33, a44, right? This is a11, a22, a33, means here I equal to j, right? So for I equal to j, we have aij not equal to 0, means these non diagonal elements are not the 0. So this is the diagonal matrix. Next type of matrix is the identity matrix, or you can say the unit matrix. So what is the identity matrix? A diagonal matrix with ones on the main diagonal. Means we have suppose this matrix. Which type of matrix this is? This is the, you can see that this is the diagonal matrix, right? Because only in the diagonal we have the elements and non-diagonal elements are 0. But what is the difference between the diagonal matrix and the unit matrix? Here in diagonal matrix we have any one elements are there, 1, 2, 3, 4 different elements may be there in the diagonal matrix, but in the identity matrix all diagonal elements should be 1. So this type of matrix is the identity matrix. Suppose we have this, so here our diagonal elements are 1, 1 and non-diagonal elements are 0. So this type of matrix is the identity matrix. So we can say that if we talk about the aij, so aij should be equal to 1 for I equal to j and non-diagonal elements are 0. So this is the identity matrix. Next is the null matrix. Null matrix, or you can say the zero matrix. So what is the zero matrix? If all elements of any matrix are 0. So this is the null matrix, right? Suppose we have this. This is the zero matrix. All elements of this matrix is 0. So this is called the null matrix. If we have suppose this, so here you can see that all elements of this matrix are 0. So this is the null matrix. Clear? All ij, for all ij aij equal to 0. Next one is the triangular matrix. So what is the triangular matrix? A square matrix whose elements above or below the main diagonal are all 0. Means what is that? If suppose we have this type of matrix, right? So this is our the main diagonal, and what is the triangular matrix? Main diagonal below or above. So here you can see that above the main diagonal, above element of the main diagonal, these all are 0, right? Above the main diagonal element are 0. So this is called the triangular matrix. Similarly, if we have this type of matrix and here this is our the diagonal, and we can see that our below the diagonal elements are all 0. So this is a triangular matrix, right? What is the triangular matrix? Next is the upper triangular. In a triangular matrix, we have the two types of matrix: upper triangular matrix and the lower triangular matrix. So, what is the upper triangular matrix? A square matrix whose elements below the main diagonals are all zero. So that type of matrix is called the upper triangular matrix. Suppose we have this type of matrix, elements are Aij type. So what is the main diagonal? This is the main diagonal, and we can see that below the main diagonal elements all are zero. So if we have the below the main diagonal elements are zero, so this type of matrix is called the upper triangular matrix, right? Similarly, here we have, what is the diagonal of this matrix? This is the main diagonal, and we can see that below the main diagonal elements are zero. So this is the upper triangular matrix. Clear? Similarly, if we have the 4 by 4 matrix, and for these type of matrix, it should be there, the matrix should be square matrix, because diagonal exists in only the square matrix. So this is our the main diagonal, and we can see that the below the main diagonal elements all are zero. So this type of matrix is called the upper triangular matrix. Clear? So we can say that for all I is greater than j, aij equal to 0. You can see here I is greater than j. What is I? I represents our the rows and j represents our the column. Clear? Next one is the lower triangular matrix. So what is the lower triangular matrix? A square matrix whose elements above the main diagonal are all zero, above the main diagonal, right? So if we have, suppose, this type of matrix, so here what is our diagonal elements? This is our the main diagonal, and we can see that our the, sorry, not this one, this one above the main diagonal elements, these all are the zero. So this is the lower triangular matrix. Similarly, if we have the this type of matrix, and this is our the main diagonal, and the above the main diagonal elements, this one above the main diagonal elements all are zero. So this is our the lower triangular matrix, right? So if I is less than j, then aij equal to 0. So this is the up lower triangular matrix. Clear? Next one is the scalar matrix. So what is the scalar matrix? A diagonal matrix whose main diagonal elements are equal to the same scalar. What is the difference here? A scalar is defined as a single number or constant. That scalar must be any constant, right? So here, suppose this type of matrix we have. So this is our the main diagonal. So if the scalar matrix, this is the diagonal matrix simply, right? You can see that this is a diagonal matrix, because only diagonal elements we have, non diagonal elements are zero. But when it will be the scalar, it will be the scalar if all aij are the one scalar value, means like that 1 1 1, or you can say that like that. Here, this is also called the identity matrix, or diagonal matrix, or scalar matrix also, because scalar matrix property is that the main diagonal elements are all are equal, or any scalar value, any 1 2 3 4, any, but all the diagonal elements should be same. So this type of matrix is the scalar matrix. Clear? So you can say that for non-diagonal elements are 0, and for diagonal elements I equal to j, we have the aij equal to a, means a scalar value, means all diagonal elements are equal. Clear? Next one is the transpose of a matrix. So what is the transpose of a matrix? If we have the a matrix A, and the elements are aij is m cross n matrix, right? Means rows, and here we have not the square matrix, rectangular matrix where we have the m rows and n columns, then the transpose of a is this a transpose equal to aij transpose, means we denote our transpose by a transpose, and it is defined as n cross m matrix, means if our rows are converted into the columns and columns are converted into the rows, then matrix we form, that is our the transpose of the matrix. Suppose we have this X matrix, so this is our the, because only we have here the one column, so this is the column matrix. Now when we take the transpose of this here is X dash. Actually dash is also the representation of the transpose of the matrix. So you can also write this is by the X transpose, right? You can also write that X transpose, and this is the now our column converted into the row, so this is the transpose of this matrix. Clear? If you have suppose this type of matrix, so here this matrix is the 3 by 4 matrix, means 3 rows are there, 4 columns are there, so 3 cross 4. When you take the transpose of this, so this is the A transpose, means your row, your column is converted into the rows and your row is converted into the your column. So that is the transpose of the matrix. If your rows converted into the columns and your columns converted into the rows, then you find that matrix, that is the transpose of the given matrix. Clear? So here we have the some property of the transpose of the matrix, that is, if you have the two matrices A and B and K is any scalar quantity for belongs to the real number, so A transpose of transpose, that is equivalent to matrix A. If you have K is any scalar quantity, so K A transpose, this is equivalent to K A transpose, because A is the matrix here and K is any scalar quantity, right? So no doesn't affect the transpose in any scalar quantity. Next, A plus minus means maybe plus or minus here. So A plus B transpose, this is equivalent to A transpose plus B transpose. Similarly, A minus B transpose, this is equivalent to A transpose minus B transpose. Clear? Next is the symmetric matrix. So what is the symmetric matrix? If your A transpose is equal to A, suppose you have each like that matrix A, in which when you do the transpose of that matrix, so that transpose is again you will get your given matrix. So that is the, this type of matrix is the symmetric matrix, means your Aij equal to Aji. You can see is like that if you have this type of matrix A, right? So here when you take the transpose of this, transpose means your row is 514, you can change it is column 514. Your row is 1 2 minus 2 and your column is 1 2 minus 2. When you take 4 minus 2 3 and you're now 4 minus 2 3. So when you take the transpose, but you can see that you will get the same matrix, right? So this is the symmetric matrix where A transpose is equal to A. Next one is the skew-symmetric matrix. What is the skew-symmetric matrix? If your A transpose, this is equivalent to minus of A, means when you can take the transpose of the matrix A and it will be the equal to of minus A, so your matrix is the skew-symmetric matrix, means Aij equal to minus of Aji. And one more thing is that the diagonal must contain zeros. In skew-symmetric matrix, all diagonal elements will be 0, like that. If we have this type of matrix, you can say that this matrix is the skew symmetric matrix. How? Because first thing is that diagonal elements all are 0, and you have to satisfy this property, means when you take the transpose of this, when we take the transpose 0 1 minus 4, 0 1 minus 4, so here we have the 0 1 minus 4 minus 103, so you can take column minus 107, sorry, and when you take your row 4 minus 70 and you take here 4 minus 70, so now you have this A transpose. Now when you take the minus here, so when you take the minus, so minus you have to multiply it here, so this becomes 0 minus 1 4 1 0 minus 7 minus 4 7 0. Then you can see what is this matrix. This is your given matrix A, right? This is your given matrix A and minus of A. So you can check here A transpose is equal to minus of A. It means that you can say that this A matrix is the skew symmetric matrix. Clear? Next one is the row echelon form. So what is the row echelon form of the matrix? Matrix A is said to be in row echelon form if it satisfies the following properties. Which properties? If you have suppose this type of matrix A, here you have this type of matrix, so this is in echelon form. How can you say this is in echelon form? First property should be there: rows consisting entirely zeros occurs at the bottom of the matrix. Here you can see that here this is entire row has the zero elements, right? Second one is, for each row that doesn't consist entirely zeros, the first non-zero is 1. First non-zero, this one. First non-zero is 1. And for each non-zero row, number 1 appear to the right of the leading one, like one, this one, of the previous row. Means like that, the leading one. Here the first, this one thing is there. First row non-zero is 1, and if first one is 0 suppose, then the leading one, right, appear the right of this, that should be 1. So this is this type of matrix is the echelon form matrix. Similarly, if we have this matrix, this is a echelon form. Yes, because here what? Here we have these one leading ones are there. These are the leading one. So this type of matrix is called the echelon form matrix. These matrices are you are using your to find the rank of the matrix. So further we will discuss about the rank of the matrix. So where we use this echelon form matrix. Clear? So now thank you. Today's lecture is completed now. Be happy, be healthy.